Hello, this is Mr. Young, and welcome to Lesson 3.6, Characteristics of Phase Change. Before we begin, please take out something to write with and something to write on. You'll find these notes useful on assignments, labs, and assessments. By the end of this lesson, you should be able to describe phase changes, explain how temperature can be used to recognize a phase change. You should be able to define and correctly use vocabulary words, phase change, and heat of fusion. Melting, freezing, vaporization, condensation, sublimation, and deposition are the 6 common phase changes. When at least 2 states of the same substance are present, scientists describe each different state as a phase. A phase change is the reversible physical change that occurs when a substance changes from one state of matter to another. The diagram lists 6 phase changes that can occur among the solid, liquid, and gaseous phases of a substance. Each arrow in the diagram represents a different phase change. All phase changes share certain characteristics related to energy and temperature. What happens to a substance's temperature and a system energy during a phase change? One way to recognize a phase change is by measuring the temperature of a substance as it is heated or cooled. The temperature of a substance does not change during a phase change. This is a graph, the data collected when water is slowly heated. Please look at the segment AB. The temperature of the water rises until it reaches 0 degrees Celsius at point B. The temperature remains at 0 degrees, line segment BC, the melting point of water, until melting is complete. If liquid water is cooled, its temperature will drop until it reaches 0 degrees Celsius. It will remain at 0 degrees Celsius until the liquid freezes completely. The temperature at which a substance freezes, its freezing point, is identical to the temperature at which it melts, the melting point. The difference between melting and freezing depends on the direction of the energy flow. If energy flows into the water, then it will melt. If energy flows out of the water, then it will freeze. If liquid water is heated, its temperature keeps rising until it reaches 100 degrees Celsius, the boiling point of water, as shown in segment CD. The temperature remains at 100 degrees Celsius until water is completely transformed into a vapor, as shown in segment DE. Again, the direction of the phase change, liquid to gas or gas to liquid, depends on the flow of energy. If energy flows into the liquid, it transforms into a vapor or gas. Energy flows out in the transition from gas to liquid. During the phase change, energy is transferred between a substance and its surroundings. Sometimes we'll refer to the substance as a system. More about that in physics next semester. The direction of the transfer depends on the type of phase change. Endothermic is when energy is absorbed or flows into the substance or system. Exothermic is when energy is released or flows out of the system or substance. By now, you should be able to describe phase changes, explain how temperatures can be used to recognize a phase change. You should also be able to define and correctly use the vocabulary words phase change and heat of fusion. We hope you enjoyed our lesson.